Alright guys, Mr. T here, another video. This is going to be about speed, flow rate, density and other rates. This is going to help you out with exercises 2E.1 to 2E.4. They're all very similar. I figured I'd just do one video to cover them all. So some commonly used rates that you're going to encounter are speed, flow rate and density. Now even though they measure very different things, the questions involving them can be done really similar way. So I'll show you with speed to start off with. Speed, so you would experience that every day. The general speed limit around Adelaide is 60 kilometers per hour. So kilometers is a distance per hour, hour is a time. So really speed is a distance per time measurement. So you can write that as speed is equal to distance divided by time. You can actually summarize this with a triangle, okay? Put speed on the left down here, distance on the top, because distance is up the top there, time on the bottom as well. And you can actually use that diagram, this triangle. You can find any of these three units in a question by covering up the one you're trying to find. So if I want to find the speed of something, I cover up S, and I would get the distance, divide it by the time, and that would be my speed. Alright, involving the units that the distance and the time were found in. So let's run an example using that diagram, because you're going to be able to use this for any kind of rates. If I wanted to find the average speed of the car of a car that travelled 750 kilometers in 7 hours, I would be covering up S, and I would need to divide a distance by the time. So, speed, V of C is equal to the distance, 750, divided by the time, 7 hours. So, get my calculator. 750 divided by 7. That comes to 107.14 to 2 decimal places. And what were the units in? Kilometers and hours. So, it's going to be kilometers per hour, and I'll write it like the book does, to the hours to the power of -1, because it's kilometers divided by hours, and write that I approximated it to 2 decimal points. Alright, next one, let's show how you find one of the other units here. So this time I want to find the time taken for a car to travel 300 kilometers, average speed of 90. So this time I'm trying to find T. So what's left over if I'm covering up T? Distance divided by speed. So this time the time is going to be the distance, 300 k's, divided by the speed, 90. 300 divided by 90 comes to 3.33 recurring, and that was kilometers per hour and kilometers, so it's going to be in hours. It's going to take 3.33 hours for a car traveling at 90 to get to travel 300 kilometers, and I rounded that to 2 decimal places as well. So that's just a little example. I haven't done the finding the distance. It works exactly the same way. All rates, okay, can be used with the similar system. All rates can have the same method applied to find each variable involved. So let's show you with flow rate as well. Flow rate is a volume per unit time, so it's going to be flow rate is equal to the volume divided by the time. Therefore the triangle is going to look like this, similar to speed. So if I had a question saying a 12 litre bucket takes 30 seconds to fill from a tap, what's the flow rate of the tap? This is obviously an example from the book. Flow rate from the triangle is going to be the volume, 12, divided by the time, 30 seconds. And you'll see I'm working it out slightly different to the book. 12 litres divided by 30 seconds, because I'm going to find it in litres per second. So it's going to be 0.4 litres per second. S -1. I didn't have to round here, it's exact, so I'm going to leave it like that. Now the book works it out to litres per minute. Well, how many minutes are there? How many seconds are there in a minute? There's 60. So there, if I times 0.4 by 60, that'll give me the same answer as the book. So 0.4 liters per second is equal to 0.4 times by 60 liters per minute is equal to 24 liters per minute, which is just like the book. Okay, I don't have any particular way that I want you to find out questions. There's no right or wrong way. Well, there is a right or wrong way. There's just many different ways to find them. Okay, so if you use the right maths or use a different way with correct maths, you're always going to be fine. You don't need to work it out in one way that you think I expect you to work it out with. Next one, density. That is a mass per volume. It tells you how much stuff there is in a thing, in a space. It tells you how much stuff there is in a particular measured space. So density is mass divided by the volume. You get the triangle there, mass on top, density on the bottom, and volume on the bottom. So let's run this question. Aluminium has a density of 2.7 grams per cubic centimeter. So the space is cubic centimeters, and it's that many grams, 2.7 grams in each of those. What mass would an aluminium bar be with dimensions 2.4 meters by 10 centimeters by 5 centimeters? So first thing we need to do is we've only got dimensions here. We don't know what the volume is, so we need to work out what the volume is. 2.4 meters is 240 centimeters times by 10 centimeters times by 5 centimeters equals 10 times by 5. It's got a volume of 12,000 cubic centimeters. So now we can find this mass. I think it is. Yes, you're finding mass here. So if I'm finding mass, I need to cover up m. So I need to do density times by the volume. The density is in the correct units now, so mass equals density 2 point. So I'll erase that. It's 2. The density is 2.7. These videos are hard to do when you have to do them perfectly at once. 2.7 grams per centimeter cubed is the density, times by the volume, which we worked out to be 12,000. 12,000 times by 2.7. That's going to be 32,400 grams. So hopefully that's what it says in the book. Yes, 32,400 grams. I don't know why they converted to 32.4 kilos. It doesn't ask to do that, so this is fine. Okay, and then finally the last set of questions that you're going to have to do in this little section is other rates. So when we first talked about rates in my first video about rates, I said rates are just a comparison between any different values. So for any situation where you have an amount of one thing for an amount of another thing, you will be able to find a rate. So you cannot remember absolutely every different comparison for every different rate. You can work it out. So if a family used 204,000 litres of water per year, and we wanted to find the rate of water usage per day, you just have to do the math like below. Okay, water usage per day is going to be the amount of water they used in the year divided by, well, we want to find per day. We just need to work out how many days in a year. Well, a normal year has 365 days, so it's going to be 204,000 divided by 365. It's going to be 204,000 divided by 365. It's going to be 558.9 litres per day, or litres day, -1 to 2 decimal points. Alright, so that is your video on speed, density, flow rate, and other rates. Probably the easiest is other rates, but you will need practice on that. Hopefully that's helpful to you, and I will see you on the next video. Mr. T out.